So, hi everyone, in this video we will be doing class 10th exemplar exercise 2.3. So this exercise is very important with respect to practicing on how to solve a given quadratic polynomial, right? So the question is find the zeros. So the question is find the zeros of the following polynomials by factorization method and verify the relationship between the zeros and the coefficients of the polynomials. So if you are given a quadratic polynomial and if you have to find the zeros, the very first thing that you have to do is you have to equate it to 0. Okay, so let's do that. Whenever you have to find the 0, to find zeros you have to equate the polynomial to 0. Okay, so let us equate it to 0. So 4x square minus 3x minus 1 is equal to 0. Here there are two values specifically. One is nothing but the sum as well as the product value. Okay, so the sum is nothing but the sum is nothing but the value of your b. Okay, that's your sum, which is nothing but minus 3, and the product is nothing but a into c. So you have your a is nothing but 4 and c is nothing but your minus 1. So always equate this in the this is of the form ax square plus bx plus c. Okay, so you have to equate it and compare it with the standard form of a quadratic polynomial. Okay, so whenever you are given a quadratic polynomial, always remember your sum will be just the value of b, that is the coefficient of x will be your sum, and the product will be a multiplied by c will be your product, which is nothing but 4 into minus 1, which is nothing but minus 4, right? So you have to think of two numbers whose sum is minus 3 and whose product is minus 4. So 4 into 1 is 4, and if you put a negative sign to 4, then the sum will be negative, right? So let us do the middle term splitting here. You have 4x square minus 4x plus x minus 1 is equal to 0. So you have 4x common out, you have x minus 1, again plus 1 common out, again x minus 1 is equal to 0. So between the two terms you can take, say, x minus 1 is common and the other term is nothing but 4x plus 1 is equal to 0. Okay, so either x minus 1 is equal to 0. Okay, so either x minus 1 equal to 0 or 4x plus 1 equal to 0. So x is equal to 1 and here x is equal to minus 1 by 4, right? So these two are the zeros of the given quadratic polynomial. Okay, so the zeros of the given quadratic polynomial are 1 and minus 1 by 4. What the question also says, apart from finding the zeros by factorization method, so we have used the middle term splitting method, you also have to verify the relationship between the zeros and the coefficients. So here the coefficients are a is nothing but 4, b is nothing but minus 3 and your c is nothing but minus 1. Right, so let us write the coefficients and the zeros separately. So let let alpha and beta be the 0. So alpha is nothing but 1. Your beta is the other 0, which is minus 1 by 4. And your coefficients, so these are the zeros, and the coefficients are a is nothing but 4, b is nothing but minus 3, and your c is nothing but minus 1. So these are the coefficients, right? Now in order to verify the relationship between the coefficients as well as the zeros, we have the sum of the zeros equal to minus b by a. So let's add up the zeros, that is 1 plus of minus 1 by 4. So which is nothing but 1 minus 1 by 4, which is 3 by 4. Okay, is equal to minus of b is minus 3 by 4. So which is nothing but this is also equal to 3 by 4. Right? So you have verified one part of it, which is nothing but your sum of the zeros. Similarly, product of the zeros also you have to verify, wherein the formula is alpha beta equal to c by a. What is alpha into beta? So 1 multiplied by minus 1 by 4, which is nothing but minus 1 by 4. What is your c? C is minus 1 and a is 4. So this is equal to minus 1 by 4, right? Hence verified. So similarly, let's do the second question. So you are given a quadratic polynomial, and let us compare it with the standard form of the quadratic polynomial. So your a is 3, your b is 4, your c is minus 4. And in order to find the zeros, you have to equate the polynomial to 0. Right? So let us equate it to 0. So 3x square plus 4x minus 4 equal to 0. You have to have a sum and a product value. Sum is b, b is nothing but 4, and the product is minus 12. 3 into minus 4, right? 3 into minus 4. So 6 2s are 12. If you put a negative sign to 2, your sum is plus 4. So 3x square plus 6x minus 2x minus 4 is equal to 0. Right? Take 3x common out. So you have x plus 2 minus 2 common out, again x plus 2 equal to 0. So x plus 2 is common among the two terms. The other term is 3x minus 2 is equal to 0. So what are the zeros here? Either x plus 2 is equal to 0, which means x is equal to minus 2, or you have got 3x minus 2 equal to 0, which means 3x is equal to 2, or x is equal to 2 by 3. So these are the zeros. So let alpha be minus 2. Your beta is nothing but 2 by 3. Right? Now, what are the coefficients? Your coefficients are a is nothing but 3, your b is nothing but 4, and your c is nothing but minus 4. In order to verify, let us verify the relationship. So alpha plus beta is equal to minus b by a. What is alpha? It is minus 2 plus 2 by 3. So you have your LCM is 3. So 3 into minus 2 is minus 6 plus 2, which is nothing but you are getting it as minus 4 by 3. What is our minus of b is nothing but 4 by 3. So your RHS is also minus 4 by 3, hence verified. And the product of zeros, alpha beta is equal to c by a. What is alpha? Minus 2 multiplied by 2 by 3. So you have minus 4 by 3 is equal to c by a. C is minus 4, a is 3. So either LHS equal to RHS, hence proved or hence verified. Okay, so this is how you have to do. Let us move on to the next question. So the next question is your 5t square plus 12t plus 7 is the next question. The very first thing that you have to do is let us equate it to 0, right? So 5t square plus 12t plus 7 is equal to 0. So to find the zeros, you have to equate the polynomial to 0 and get sum as well as the product. So sum is nothing but 12, which is the value of your b, and product is nothing but 5 multiplied by 7, a into c. So you have 35, and we know 7 5s are 35. So 7 and 5 are the two numbers for your middle term splitting. So let's write that 5t square plus 7t plus 5t plus 7 is equal to 0. You can take t common out. So you have 5t plus 7. Again plus 1 common out. You have 5t plus 7 equal to 0. So 5t plus 7, the other term is t plus 1 equal to 0. So either 5t plus 7 equal to 0, which means t is equal to minus 7 by 5, or you have t plus 1 equal to 0, which means t is equal to minus 1. So these are the zeros of the given polynomial. Let one of them be alpha, the other one is beta. And what is your a, b and c? The coefficients, a is nothing but 5, your b is 12, and your c is nothing but 7, right? Now let's verify it. So to verify, alpha plus beta equal to minus b by a. What is alpha? Minus 7 by 5 plus what is beta? Minus 1. So let's get minus 7 by 5 minus 1, right? So the LCM is 5. You have minus 7 minus 5, which is nothing but minus 12 by 5 is equal to, what is minus b? It is minus 12 by 5. So you are getting even the RHS is minus 12 by 5. Okay, now let us verify the product of the zeros. Okay, let's verify the product of the zeros as well. So we know alpha beta is equal to c by a. So what is your alpha? Alpha is minus 7 by 5 multiplied by minus 1. So this is nothing but 7 by 5. Your c is 7 and your a is 5. Okay, so 7 by 5. So hence verified. Now let's move on to the next question, which is nothing but 2x square plus 7 by 2x plus 3 by 4. Okay, so here the first thing that we have to do is take the LCM 4. So the numerator becomes, the first term is 8, 4 into 2, 8x square plus 2 into 7, 14x plus 3. Okay, so if you take 1 by 4 common out, you will get 8x square plus 14x plus 3 is equal to 0. So in order to find the zeros, you have to equate the polynomial to 0. Here, so when you cross multiply, 4 multiplied by 0 becomes 0. So what you have, the polynomial that you have here is 8x square plus 14x plus 3 is equal to 0. So your sum, the product value sum is b, which is 14, product is 24. Okay, so 12 into 2 is 24. So let us go ahead, do the middle term splitting. 8x square plus 12x plus 2x plus 3 is equal to 0. So you can take 4x common. You will have 2x plus 3. Again plus 1 common out. 2x plus 3 equal to 0. Between the two terms you have 2x plus 3 common out. 4x plus 1 is left out, equal to 0. So this means that either 2x plus 3 is equal to 0, or it means 4x plus 1 equal to 0. So x is nothing but minus 3 by 2, and here x is nothing but minus 1 by 4. So let this be your alpha and let this be your beta. Let's take our coefficients, that is a, b and c. What is a? A is nothing but 2. Your b is nothing but plus 7 by 2, and your c is 3 by 4. So in order to verify, so these two are the zeros, right? These are the zeros of the given polynomial. These are the coefficients. Let's verify. So to verify, alpha plus beta equal to minus b by a. So what is your alpha? Minus 3 by 2 plus of minus 1 by 4. Your LCM is 4. So 2 3s are 6. So minus 6 minus 1. So you will be getting a minus 7 by 4 in the LHS side. Minus b is nothing but 7 by 2 whole divided by 2. So this is nothing but minus 7 by 2 multiplied by 1 by 2. So this is nothing but minus 7 by 4. Hence verified. And the product of the zeros is equal to c by a. What is product of the zeros? Minus 3 by 2 multiplied by minus 1 by 4. So you have 3 by 8 is equal to c is nothing but 3 by 4 whole divided by 2. Again, this is nothing but 3 by 4 multiplied by 1 by 2. So this is 3 by 8, hence verified. So you have to verify these two relationships with respect to the zeros as well as with respect to the coefficients, zeros and the coefficients. Let's move on to the fifth question. In the fifth question, so there are a total of say 9 questions in this exercise, and we are just in the fifth one. All the questions are of the similar type. Okay. So here also let us do the same way. In order to find the 0, you have to equate it to 0, right? Get the sum and the product value. What is sum? Sum is nothing but your b. What is your b value? 5 root 2. And what is your product? 4 multiplied by minus 3, which is nothing but your minus 12. Now you have to get two numbers. So 6 2s are 12. So I'm going to write 6 into 2. I am going to split it as root 2 and root 2. I'll put a negative sign to the smaller value so that I get a sum of plus, right? And let's do the middle term splitting. So 4x square plus 6 root 2x minus root 2x minus 3 equal to 0. So here you can take minus 1 common out. So you have root 2x plus 3. Again, in this term also you will have root 2x plus 3 should be common. So what can you take out? 2 root 2x can be taken out is equal to 0. So you have one term is root 2x plus 3 and the other term is nothing but 2 root 2x minus 1 equal to 0. These are the two terms, right? So either root 2x plus 3 is equal to 0, which means x is nothing but minus 3 by root 2, or the other value is 2 root 2x minus 1 equal to 0, which means 2 root 2x is equal to 1, or x is nothing but 1 by 2 root 2. So you can take one value as alpha and the other value as beta. And let's verify. So what are the coefficients in the given question? A is nothing but 4, your B is nothing but 5 root 2, and your C is nothing but minus 3, right? Your alpha is nothing but minus 3 by root 2, and your beta value is 1 divided by 2 root 2. These are your coefficients and zeros. So let us go ahead and verify. Okay. So in order to verify, we know alpha plus beta is equal to minus b by a. Okay, alpha is nothing but minus 3 by root 2 plus 1 by 2 root 2. So what will be the LCM? The LCM will be 2 root 2. Right? So the numerator will be minus 6 plus 1. So you will have minus 5 by 2 root 2. This will be your LHS is equal to minus b by a. So minus 5 root 2 by 4. I can write 4 as 2 root 2 multiplied by root 2. This is nothing but your 4. Right? So root 2 gets cancelled, and what is left is minus 5 divided by 2 root 2. So this is very important when you are doing a simplification. Right? Okay. And let us go ahead and do the verification of the product of the zeros as well. So we know that alpha beta is equal to C by alpha into beta equal to C by A. So what is alpha? Minus 3 by root 2 multiplied by 1 by 2 root 2. So this is minus 3 by 4 is equal to what is C? C is minus 3. A is 4. So is equal to minus 3 by 4. So you have verified both the sum of the zeros as well as the product of the zeros. Let's move on to the sixth question. The sixth question is nothing but 2s square minus 1 plus 2 root 2s plus root 2 is given to you. Here we don't have to do any middle term splitting. Let's just open it. Alright. So if you just open it up, what do you get? 2s square, open the bracket, so minus s minus 2 root 2s plus root 2 is equal to 0. What can you take common? You can take s common out, so you have 2s minus 1, again minus root 2 common out, so you have 2s, again minus 1 equal to 0. Correct? Okay, so between the two terms you have 2s minus 1 is common, and the other term is nothing but s minus root 2 is equal to 0, right? So either 2s minus 1 equal to 0, or your s minus root 2 is equal to 0. So here you have your s as 1 by 2, and here you have your s as root 2. So let one of them be your alpha, the other one is your beta. These two are the zeros of the given quadratic polynomial, 1 by 2 and root 2. Right? Now what is a, b and c? What are the coefficients that you have? A is 2, b is nothing but minus of 1 plus 2 root 2, and your c is nothing but root 2. Now let's verify. So to verify, alpha plus beta is equal to minus b by a. What is alpha? 1 by 2 plus beta is root 2. So your LCM, take your LCM is 2. So 1 plus 2 root 2 is your LHS, equal to minus b by a. Okay, so this is your minus b by a. So minus of what is your b? Again you have a minus in the b, 1 plus 2 root 2 whole divided by 2. So minus into minus is plus. What you will be getting is 1 plus 2 root 2 by 2, hence verified. On the other hand, the product of the zeros is equal to c by a. So what is alpha? 1 by 2 is your alpha. Beta is root 2 equal to c. C is nothing but root 2 by 2. Again, root 2 by 2 is equal to root 2 by 2. You don't have to solve it, simplify it. It just makes sure that it is equal. On either sides, your LHS is equal to RHS, hence verified. That's all you need to do. You just have to verify and verify the relationship between the zeros as well as the coefficients. Get the coefficients from the question, A, B and C, get it from the question. Find the zeros using factorization method and you will be able to simply verify it. Okay, so these questions are very, very important. Now let us move on to the 7th question. V square plus 4 root 3v minus 15. So whenever you have to find the 0, you have to equate it to 0. So let's equate it to 0. So v square plus 4 root 3v minus 15 is equal to 0. Your sum and the product value. Sum is b, which is nothing but 4 root 3. Product is nothing but minus 15. So we know 5 3s are 15. I am going to take 5 3 as root 3 and root 3. Okay. So 5 3s are 15, right? So 5 into 3. Why? Because you have a root 3 here. So 3 is going to split. We will split it as root 3 into root 3. Now where do we put a negative sign? You have to put a negative sign in minus root 3. Okay. So that your sum is a positive value. Okay. So v square plus 5 root 3v minus root 3v minus 15 equal to 0. So this is what you do when you do the middle term splitting. Take v common out. So v plus 5 root 3. Again minus, take root 3 common out. V plus 5 root 3 equal to 0. So v plus 5 root 3 is common among the two terms. The leftover terms is 5 minus root 3 is equal to 0. So either v plus 5 root 3 is equal to 0, which means v equal to minus 5 root 3, or v minus root 3 equal to 0, which means v is equal to root 3. So one of the value is your alpha, the other value is your beta. Okay, so let's verify it. Yeah, please ask your doubt, whatever doubt you have. Let's verify the relationships. So to verify, you need to have your ABC also. So your A is 1, your b is nothing but 4 root 3, and your c is nothing but, what is your c? Minus 15. C is nothing but minus 15, right? So in order to verify, how will you verify? Alpha plus beta is equal to minus b by a. What is alpha? Minus 5 root 3 plus root 3, which is nothing but minus 4 root 3 is your LHS. And minus b is nothing but 4 root 3 divided by 1, which is nothing but minus 4 root 3, hence verified. Okay, so just find the zeros, get the coefficients and verify using this relationship. Alpha beta is equal to c by a. What is your alpha? Minus 5 root 3 multiplied by root 3 is equal to c. C is nothing but minus 15 by 1. So what is it, the value here? Minus 5 multiplied by root 3 into root 3 is 3, which is nothing but minus 15 is equal to minus 15, hence verified. Okay, so this is how you have to do. And one of the most important part when you're doing middle term splitting is identifying these values correctly. So if you have identified these values correctly, everything else is, you will be able to do it. Now let's move on to the 8th question. Okay, so whenever you have a fraction, it's better you take the LCM and make sure that all your coefficients are whole numbers in the very beginning. Right? So you have got, say 2 is the LCM. So the numerator will have 2y square plus 3 root 5y minus 10 is equal to 0. Okay. So take 1 by 2 common out. You will have 2y square plus 3 root 5y minus 10 equal to 0. So what is the polynomial? 2y square plus 3 root 5y minus 10 equal to 0. Take the sum and the product. Sum is nothing but 3 root 5. Product is nothing but minus 20. So 4 5s are 20. So 4 root 5 and root 5. So these are the two values. If you put a negative root 5, you will get a plus 3 root 5 and a minus 20 also. Correct? So let us go ahead. 2y square plus 4 root 5y minus root 5y minus 10 equal to 0. So what is common? 2y common. So y plus 2 root 5. Again, minus root 5 common out. So you'll have y plus 2 root 5 equal to 0. Okay. So y plus 2 root 5 is one factor. The other one is 2y minus root 5 equal to 0. So either y plus 2 root 5 equal to 0, which means y is equal to minus 2 root 5, or 2y equal to root 5, which is nothing but y is equal to root 5 divided by 2. So one is your alpha and let the other 0 be your beta value. So let's verify. So to verify, what are your a, b and c values? A is nothing but, from the given question, a is 1. Your b is nothing but 3 by 2 root 5 and your c is nothing but minus 5. Alpha is nothing but minus 2 root 5 and your beta is equal to root 5 by 2. Right? Okay. So let's verify. Alpha plus beta is equal to minus b by a is one formula, and alpha beta is equal to c by a is another formula. So we are almost done. Just one more question. So let us substitute the value. So minus 2 root 5 plus root 5 by 2. Take the LCM. LCM is 2. So you have minus 4 root 5 plus root 5. So this is nothing but minus 3 root 5 by 2 is equal to minus, again, a is 1. So it's going to be minus 3 by 2 root 5. Whatever b value you have, you just have to write it. So this will become minus 3 root 5 by 2. This is your LHS equal to RHS. And what is alpha into beta? Alpha is nothing but minus 2 root 5 multiplied by root 5 by 2. So 2 gets cancelled. It is nothing but minus 5. So what is your C? C is minus 5 by 1, which is nothing but minus 5. Hence verified. Okay. So that's all you have to do. So this is the last question of the exercise 2.3. 7 minus 11 by 3, y minus 2 by 3. So again, what is your sum and what is your product? Sum is nothing but the value of b minus 11 by 3. Or before taking these values which are in the form of fractions, let's take the LCM. So LCM is 3. So what you have, 21y square minus 11y minus 2 equal to 0, right? So you have 1 by 3 common out, 21y square minus 11y minus 2 equal to 0. Which means 21y square minus 11y minus 2 equal to 0. So what is your sum? Sum is nothing but minus 11. What is your product? Minus 42, right? So 14 and 3 are the values, minus 14 and plus 3. Let's do middle term splitting. So you have 21y square minus 14y plus 3y minus 2 equal to 0. Take 7y common out, so you'll have 3y minus 2. Again plus 1 common out, you have 3y minus 2 equal to 0. So the factors are 3y minus 2 and 7y plus 1 equal to 0. So either you have your 3y minus 2 equal to 0 or 7y plus 1 equal to 0. So your y is nothing but 2 by 3. And here your y is equal to minus 1 by 7. So let one of them be alpha and the other 0 be beta. Okay. So what is your A, B, C? Here A is nothing but, you can take the values which are given in the question. 7. A is nothing but 7. B is nothing but minus 11 by 3. And your C coefficient is nothing but minus 2 by 3. Let's just verify it. So to verify, alpha plus beta equal to minus b by a. What is alpha? 2 by 3 plus minus 1 by 7. So your LCM is 21. Again 14 minus 3. So what do you get? What is 14 minus 3? 11 by 21. Equal to, what is minus b by a? Minus 11 by 3 by 7. So again this is nothing but minus 11 by 3 multiplied by 1 by 7. Minus b by a. Yeah, here it is nothing but minus of minus. Okay, so you have a minus here and b is nothing but minus 11. So this will become plus 11 by 3. Okay, so you have 11 by 21, right? Hence verified. And the product of the zeros alpha beta equal to c by a. What is alpha? 2 by 3 multiplied by minus 1 by 7 should be equal to c by a. C is nothing but minus 2 by 3 by 7. So what do you get? Minus 2 by 21. So minus 2 by 3 multiplied by 1 by 7, which is nothing but your minus 2 by 21. That's your answer. So you have verified. So in all of these questions, you have used the middle term splitting. First thing is, whenever you have to find the 0, you have to equate the polynomial to 0. Second thing is, whenever there is a fraction, you have to take the LCM and then take out that denominator common out, and when you equate it to 0, the value becomes 0. Take only the polynomial with the whole number so that it's easier for you to do the middle term splitting. Take the value of b, that is the coefficient of x or y, that's your b, that is your sum, and product is nothing but a multiplied by c. So you get the two numbers by doing the prime factorization of the product value and get the two numbers, substitute it in place of your middle term and equate it to 0, take out common, get the factors, equate it to 0, get your zeros, alpha and beta, write whatever the coefficients are and then verify using the relationship alpha plus beta equal to minus b by a, alpha beta equal to c by a. That's all. Okay, so there were 9 questions in this exercise. Please do it, and if you have any doubts, please post it in the comments and I'll definitely reply to that. So this is Chapter 2 Polynomials Exercise 2.3. There are 9 questions in it and we have done all the 9 questions in this video. Do make sure you practice it, and if you have any questions, definitely ask. See you all in the next video. That is your exercise 2.4 of Exemplar Chapter 2. Till then, happy learning.